So today we're just going to be talking about constructible numbers, what they are, and some examples of them. So we say a real number alpha is constructible if we can construct a line segment with length, absolute value of alpha, with only a unit length segment. In this case, we're going to be using 1, a compass, and a straight edge. You can also have constructible angles and whatnot, but we'll kind of see that as we move on. So now we're going to be walking through how 2 is constructible. So we start off with a line segment with unit of length 1 here, and we're just putting the compass over it, measuring that, and then forming a circle with the center of that point there that's marked. Thus we know that the radius of this circle, I didn't finish drawing it because it wasn't really necessary, but we know that the radius is 1, and thus when we draw that other line there using the straight edge, we are aware that that full diameter there is going to be 1 plus 1, so a total of 2. And thus we have constructed 2. Now we're going to be showing that we can copy a line segment. So here I'm just going to draw a quick line for us to copy, trying to make it as straight as possible. And then you go in with your compass and measure it like that. You make sure one end is on each end of that line segment, and you can then carry it over and then sketch out a bit of a quarter circle, whatnot, just mark it, and then going back in with that straight edge, you can go to any point on that circle or on that quarter circle, that mark we created, and just draw a straight line with the straight edge, and we know that that line we just drew is the same length as that line we started with. Okay, so now we're going to be showing how we can add multiple line segments together. So when we have these 3 line segments at the top, A, B, and C, we then go in with our straight edge and draw that another line segment, and then using the compass, we can measure the length of A and then bring it onto that other line segment and sketch that out. Then going into B and measuring that segment, we then want to bring the compass back down and make sure it's at the point that A ended, and then go in like that. And then again, we're going to do the same thing with C and just mark that as so. And then we know that exactly where C ends, where I kind of place that protractor, that segment is of the length A plus B plus C. Now we're going to be showing that we can divide a line segment by 2. So suppose we're going to try and divide this line segment right there. You want to start off by using your straight edge to create another line above that connected, and then using the compass, we are going to mark 2 spots because we're trying to divide it by 2. The same method works for creating n amount of, or dividing the line segment into n parts, equal parts. So after we've marked those 2 spots on that line, we're going to use our straight edge and try and measure that second point with the end of our line as so. It takes me a second to kind of get it nice and even. You do want to make sure that they're very even. It's kind of really important. And then you just match that up with the end of the line segment, and then we want to do the same with the first point we drew. And from there, we know that the line segment is divided into 2 equal parts. So now we're going to be showing how we can construct perpendicular bisectors. So to create a perpendicular bisector, we want to start off by having a straight line made from the straight edge. Then going in with the compass, you want to place it on one end of the line segment and making sure the other part of the compass is a little more than halfway. You can then create a semicircle, half circle, but with that end as the center. And then we're going to do the exact same thing on the other side. Again, it doesn't have to be an exact point. They don't have to be exactly the same point. It could be a little different. But we know that the place that those 2 intersect would be the perpendicular bisector. So therefore, we can use our straight edge and draw that line in between those intersections, like I'm doing here, just like that. And then we know that that pink line down the center would be the perpendicular bisector. Now we're going to be showing how we can construct a 90-degree angle. So you're first going to start off by creating a line segment with the straight edge, then marking a point above that line segment. It doesn't really matter where. You then want to go in with your compass and mark that point on the end of the line segment and create a circle with the center being that point. Then going in with your straight edge, you want to draw a line using that other point the circle is running through on that line segment through the center all the way to the other end, creating a diameter. Then using the straight edge again, we can draw that straight line down, and we know that that angle right there is a 90-degree angle. Now we're going to be walking through how to construct the square root of 2. So we want to first start off with our line segment of length 1. Then using our compass, we would craft a circle with radius 1 and the center being that end point that's marked there. Then after creating that circle, we can go in with our straight edge. As we've already shown, perpendicular bisectors are constructible. We can then go in and draw that line there. We can then again use our straight edge and connect those 2 points on the circle. And because we know that the radius is of length 1 here, we know that that perpendicular line has length 1. And thus by Pythagorean's theorem, we know that that line segment we just drew has the length square root of 2. So now we're going to be proving the following theorem, that the set of constructible numbers forms a subfield F of the field of real numbers. So in order to do so, we first need to show that F is non-empty. We also need to show that if A and B are elements in the constructible numbers F, then A plus B is an element in F, and A minus B is an element in F, thus showing additive inverses, that A times B is an element in F, and that A divided by B is an element in F, thus showing multiplicative inverses. We've already shown that it is non-empty. We've also already shown that we can add 2 constructible numbers and get another one. Thus it is very easy to show that A minus B is an element in F. So it's also important to note that B cannot equal 0 for A divided by B. So now showing A times B is an element in F, we're going to start off with our 2 line segments, A and B, with the following lengths. And thus we've already shown that it is possible to add these 2 line segments, or any 2 line segments. So we've constructed B plus 1, and then using the straight edge we can construct some line from the end point of B plus 1. We can also mark with our compass where A is. We can also, with our compass, mark out where 1 is, and then using the straight edge, we can connect those 2 points there. It is also possible to construct parallel lines using constructible numbers. I'm not going to prove it, but it is true. And thus we can also mark off that we know where B is, and thus we know that the 2 above and below line segments are A plus X and 1 plus B. So we know by similar triangles that the following is going to be true. That 1 plus B over A plus X is equal to 1 over A. And thus A plus AB is going to be equal to A plus X, and thus subtracting that A from both sides, we would get AB is equal to X, and thus we have shown that A times B is constructible. So now we're going to be showing that A divided by B is constructible, again, where B is not equal to 0. So we're starting off with our 2 line segments with lengths A and B. And we've already shown that we can add these 2 line segments again to get a line segment of length B plus A. We can again use our straight edge to create some line off of the end point of that line segment and mark with our compass where length 1 is. We can also again mark where B is and mark where A is, and thus connecting the line where 1 and B are on each line segment, and again creating that parallel line, which we can do, connecting A to another point on that line segment, thus marking that extra little segment right there as x. We therefore know that that bottom line, or that bottom segment has length b plus a, and that top one has length 1 plus x. And thus, by similar triangles, we know that b plus a over 1 plus x is equal to b over 1. And therefore, b plus a is equal to b times 1 plus x, and thus b plus a divided by b is equal to 1 plus x, and therefore b over b plus a over b is equal to 1 plus x, and thus subtracting over the 1 on each side, we get a divided by b is equal to x, and thus a divided by b is constructible, and thus the constructible numbers form a subfield of the reals.